So this video goes through the Edexcel IGCSE Core Practical 1, which is all to do with solubility. So before we get going with this practical, you need to have an understanding of what solubility is. So solubility is how many grams of a solute dissolves in 100 grams of a given solvent at a given temperature. Now, usually our solvent is water, but we must remember it doesn't always have to be water. In our lab, we'll use water, but solubility could refer to any solvent. And it also is at a given temperature, because we know as temperature increases, the solubility of a solid solute also increases. So we must make sure, if we're doing any sort of experiment, that we are only changing one variable, and we're not changing temperature in this core practical here. So the overarching key ideas is that we are going to make a saturated solution using a salt. We're then going to filter out the excess salt, because we will know when we've made a saturated solution when a little bit of that solute stays at the bottom of our beaker. Now, you might use a boiling tube for this experiment instead of a beaker in that first step. It just works in the exact same way. And then your last step really is evaporating that water, and usually we will do that using an indirect method, just to avoid the crystals spitting too much, to avoid them thermally decomposing, and also to avoid any loss. So loss during, if their crystals are spitting out of the container. Today we're going to be looking at Core Practical 1, which is the first required practical for the Edexcel IGCSE, and it's all to do with solubility. So we're going to be investigating the solubility of a solid, and today it's going to be sodium chloride in water. Now, solubility is how many grams of a solid dissolves in 100 grams of water. So I'm going to use 25 centimetre cubed of water today, and that is because we can scale that up by 4 to work out how many grams dissolves in 100 grams. If I put 100 grams of water in, that would mean that I would have quite a lot to evaporate off at the end. So we'll come to why that is a bit later today. So we've got measuring cylinder, and I'm going to pour 25 centimetre cubed into my measuring cylinder, making sure that the bottom of the meniscus is on 25. I've gone over a little bit, so I'm going to use this Pasteur pipette to just take a little bit out, making sure that the bottom of the meniscus is touching 25. So that's my 25 centimetre cubed, or 25 grams of water. I'm just going to place it into a beaker. Now, the whole premise of this experiment is that we are trying to work out how much of this sodium chloride will dissolve into that 25 centimetre cubed of water. So I've got here a spatula. Now, I have measured the mass of this beaker containing sodium chloride. That's very important so that we can weigh it at the end to work out how much we've added. So, taking my spatula, and I'm going to keep adding sodium chloride, stirring with this glass rod until no more will dissolve. So just stirring, and we're just doing this at room temperature, so I can see that it has all dissolved. It does look a little bit cloudy, but I think that's just the camera angle. So keep stirring till it all dissolves, and I'm going to add another spatula full. And I'm just stirring with my glass rod until we get a saturated solution. So, do you remember what a saturated solution is? That is when no more of our solute will dissolve in our solvent. So I am trying to see, and I might need to at this point, look underneath to see if there's solid at the bottom. So I'm giving a good old stir to make sure that I'm absolutely certain that no more will dissolve. And I think I've got it there. I think I've got some solid at the bottom. Okay, now I'm going to make sure my glass rod is between two pieces of equipment so it doesn't roll off my bench. I'm then going to go and measure the mass of my beaker. And now I can work out the difference of how much sodium chloride I added to my water. Now, we want to get rid of that excess that is in there. So we're going to need to filter. So the next step is filtration. We're going to filter our crystals into this evaporating basin. But before we do that, we need to make sure we measure the mass of this evaporating basin so we can work out how much solid we've got at the end. Now usually we filter into a conical flask, but today we're just going to filter straight into our evaporating basin. So what we want to be able to do is we want to be able to evaporate off all of the water to work out how much sodium chloride dissolved in that solution. Before we do that, we are fluting our filter paper. So I folded it in half again, and I've got my filter funnel here. Now I'm filtering just to get rid of the excess sodium chloride that did not dissolve, because remember we made a saturated solution, so some solid has been left behind. Okay, it's going to make sure all of that solution goes through our funnel. The sodium chloride that gets trapped in the filter paper is called the residue. We don't want that because that was the excess that did not dissolve. We're trying to work out how much dissolved, how many grams of our sodium chloride dissolved in our 25 centimetre cubed, or our 25 grams of water. Now, what we're going to use today is called indirect heating. Now, normally we would put our evaporating basin with our solution straight onto the gauze, but today we're not going to do that because we don't want our crystals to spit. We also don't want thermal decomposition, and we don't want that liquid evaporating too quickly to damage those crystals. So we're going to take some regular water, tap water in a beaker, and we are going to place our evaporating basin on top of that. Now what that does is it creates a water bath, and I'm just going to pop, making sure that my air hole is open. Okay, so I'm going to pop my... So I've got my flame going, and I'm going to heat it up until we start to see crystals forming around the edge. We're not going to heat it up until dryness, which means we're not going to heat it until all of the liquid has gone, because this could lead to thermal decomposition of those crystals. So what we're going to do is we're going to heat it up until the water, lots of the water has evaporated and we start to see crystals, and we're going to leave it overnight for the rest of the water to evaporate, and then we'll be in a position to measure the mass of our crystals inside our evaporating basin. So we're going to filter our crystals into this evaporating basin. But before we do that, we need to make sure we measure the mass of this evaporating basin so we can work out how much solid we've got at the end. Now, I've come back in the morning and I've got my crystals in my evaporating basin. Now what I'm going to do is I'm going to measure the mass of these crystals, and then I will be able to work out my solubility. So remember, the mass of those crystals, and we need to times that mass by 4 because we added 25 grams of water, we didn't add 100 grams. And remember, solubility is grams per 100 grams of water. So I will show you in a second how we do the calculations for this. So during this experiment, you would have made a number of recordings of different measurements. So the first thing you would have measured is the mass of your container with your salt in at the start, which was 25 for me. The mass of container with the salt in at the end, and that was 16.2 for me. And then I just worked out the difference, and that came to 8.8. So I know that I added 8.8 grams of my salt, in this case it was sodium chloride, to the water. Then I've got an empty evaporating basin, so I just measured the mass of that. And then I measured the mass of the evaporating basin plus the solution. And then we were able to use those values for a calculation later. Then, once I've evaporated off all of the water, I'm left with this value here. So I've just got the crystals and the evaporating basin. And I can use that to work out the mass of the salt in my evaporating basin. So let's see how we might do that. So firstly, to work out the mass of salt in the evaporating basin, I've worked that out as 8.5. All I've done there is I've subtracted my evaporating basin mass from the mass of the evaporating basin with the dry crystals. And then to work out how much water was in our solution, I just subtracted these two numbers from each other, because this number is the solution, so that means the basin, the salt and the water, and this is just the basin and the salt. So what is left is the water. And we can use an equation like the one below to help us work out the solubility. So sometimes in an exam question they will give you an equation, sometimes they don't, so you need to be ready for any eventuality. Now I know that in my final experiment 8.5 grams of solid dissolved in that 25 centimetre cubed of water. So 8.5, my mass of my solvent, actually I subtracted it here, but you also knew that you had 25 grams, you started with that, then times that all by 100, and then our solubility comes to 34 grams per 100 grams of water. Now I'm going to show you an alternative method which is not ideal, but it's just another way that you could do it, because often our questions don't have nice numbers for us to use like 25. But because I do have a nice number like 25, I know that I can just times up the mass that I've got at the end by 4, because I know that in 100 grams I'm going to have 4 times the amount that was dissolved in 25 grams. But again, I've given that as an alternative method, but generally that doesn't work for exam questions because you don't always have nice numbers like that. Now, you could get asked some questions about solubility. You know, the real solubility of sodium chloride is 36 grams per 100 grams of water at 25 degrees. So you could get asked questions like, why did your value not match that? Or comment on the accuracy of your solubility that you've calculated. So we might have had a lower solubility because we might have had loss during transfer. We might have had some sort of systematic error, like not zeroing the balance before. And a suggestion would be, to improve our accuracy, we could have repeated this experiment and taken an average, because often that helps us get closer to the true value.